Here we go, guys. We are live. Welcome, Windows Insider, to this month's webcast. Got some exciting stuff today. We're going to talk about Windows on ARM, and we'll turn it right over to Jason to get things going so we can dive right in. Jason?
I know Eddie has done a ton of hard work from last month to this month. We had a few snags last month that provided some interesting challenges, but hopefully we are past all of that. We have some fantastic guests today. I cannot wait to introduce them. Fantastic. It says we sound clean. Good. I love to hear that. Eddie,
Yay.
Thank you once again for all of the hard work over the past month. I know we've done several tests. You've made a ton of changes on the software side. I know there was a few long nights and some sessions of frustration that we worked through just trying to get things set up correctly. Migrating to a new platform is not easy. We felt some of that pain, but again, just a shout out to Eddie and then everybody else on the inside who helped him through testing and working through all that, and hopefully we're good to go now. So let's get this thing rocking along. Today is September the 15th, 2020, the year that everybody wants to speed through as quickly as possible. Sorry, I'm just trying to be funny this morning. What are we talking about today? Today is Windows on ARM Day. We have a few fantastic guests. Hari is here. I think some of you might remember him from Build, where we had him on a webcast. He did a few demos. We had some really awesome conversation. And then one of his counterparts, Niraj, to come on and talk about Windows on ARM, go through some fantastic demos, and we will hopefully educate you on a few things today. Maybe some things you already know, take a little bit of a forward look, and then just talk about some of the cool stuff that's happening in the Insider program along the way. Also, apparently Jen is showing something on the screen that we can't read. At least I can't read.
It's Windows with ARMs.
So Brandon and obviously Jen are here with us as well. So rather than me sitting here talking, I will allow everybody to actually introduce themselves. You know Eddie. Eddie is the one who kicked us off. So Hari, if you could take a moment and introduce yourself to the audience.
Hi, I'm Hari. I'm a group manager here in Windows for sort of the Windows kernel. I run the Windows on ARM program for Microsoft. And I also do some server management stuff in my spare time as well. So very excited to be here. Long time fan of Windows Insider.
Awesome. And we will jump down to let's see, I'm looking at the Twitch stream to see what order we have them organized in, because it's a little bit different than the view that I see. So top right corner, Jen, you want to say hi, Jen?
Hi, Jen.
Okay. Bottom left is Eddie. As you know, Eddie, do you have any fun words to say as we kick off here?
Nope, nothing fun to say today.
All right.
I'm all business today.
All right. In the bottom center, we have Niraj. Niraj, please say hello.
Hey guys, my name is Niraj. I am a PM lead here in the Windows kernel team. I work with Hari on many of the Windows kernel projects, including Windows on ARM, and super excited to share, what we've been up to today.
Awesome. And then, of course, in the bottom left corner, Brandon, he's wearing a red shirt today. That's kind of scary because, well,
aren't they the ones
Star
that get
Trek.
off?
It's Star Trek.
Yeah, I thought bad things happen to the Star Trek people that wear the red shirts.
Not on the Star Trek Next Generation.
Oh.
Noted.
I'm gonna get some Star Trek junkies sending me hate mail for that one. I just always under the impression that if the red shirt guys or gals, they always had the bad things happening to them. So I was hoping this wasn't sort of a forbearance of the webcast today or some doom news you're gonna drop on us, Brandon. Good to know that's
no news or doom or anything like that.
Okay, good. All right. Well, hey, Hari, Niraj, thank you both for making the time to come join us today. I realize that ARM isn't something that in the course of the Insider program that we've spent a lot of time on, which is part of the reason I wanted to reach out and have some discussion. I think honestly that aside from mentions in some of the build blogs along the way, when a specific feature launches. And there's a cat. Of course, there's always a cat in the stream with Jen. Of course, through some of the build blogs and things that we've covered along the way, and then the guest appearance from you at Build previously. I don't think this is a space that we've given enough attention to, because we do have a very dedicated base of insiders who love Windows on ARM, constantly asking us questions, constantly clamoring for more insights and features. And, well, today is that day, because this entire episode is dedicated to this particular feature, this functionality, and I don't want to sit here and ramble on too long. I would love to turn the show over to you. I know we've got some PowerPoint material to cover, maybe a few demos. We took some pre-submitted questions and answers from insiders. Some of those, the answers are kind of incorporated into the presentation. So you'll notice some of those questions are already covered. And then I have a gigantic list that we also collated off the side, off of social media. We dropped out a form, and insiders definitely responded in kind with sending us questions. And so we'll get to as many of those as possible. There are some questions that we can answer, some questions that we can't answer. So we'll do our best to kind of dodge and dive through those as we can. So without further ado, allow me to turn it over to you, and the show is yours, sir.
All right. Thank you, Jason. Can you hear me? All right. So before I start, I want to tell you I am doing this entire presentation from my Surface Pro X. And so it's all Windows on ARM. It's all ARM all the way. So hopefully nothing crashes. We'll see. So I did this talk a couple of years ago in Build, and I'm trying to use a lot of the slides that I used at Build at that time. And for those of you in the insider community, you already are having an ARM device. A lot of this should just be reinforcing the points. But I am also not going to presuppose everybody knows what ARM is. So I'm going to give sort of the groundwork and history of how we came here, sort of, and how we came to this point. And just to give you some history context here, I actually started the Windows on ARM program many years ago. And so I've been here since day one. And so if you have questions, we can talk about it at the end of the presentation. So the thing we want to do with Windows on ARM is that we're trying to birth a whole new category here. At the end of the day, we call it a always connected PC, but really at the end of the day, it's just a PC. But it's one that provides you with the mobility and the simplicity of a phone, right? You get the power of a PC and then the mobility of a phone. And it's just a PC. There is no special SKU here. At the end of the day, it's just Windows 10. You have the same things you always use on Windows 10. You got your Edge, you got your browser, you got the shell. Everything looks the same, feels the same, uses the same, except that it's running on a new processor, and the processor is ARM, right? And so the key attributes that we think are valuable here of an always connected PC are LTE connectivity. The OS itself allows you to seamlessly switch between like LTE and Wi-Fi. If you have a SIM card in it, it'll use the SIM card. If you have Wi-Fi, it'll use the Wi-Fi. If your SIM card is metered, then we'll try to use the Wi-Fi more. So just the OS is designed to handle LTE and Wi-Fi seamlessly. Battery life, that is one of the key attributes of this Windows on 10 and ARM device, right? Or the always connected PC. If you've used an Windows 10 on ARM device, you will notice that you get an amazing battery life. You get days of use, not hours of use. This is actually one of the most freeing aspects of Windows 10 on ARM. Like, you use it and you can keep on using it for days, and you don't need to run around with your power card. Instant on. After battery life, I think this is the next thing that I really come to appreciate, and has sort of changed my expectation of a PC. I leave a machine off for the weekend, leave it at work, come back on Monday, turn it on, hit the power button, and it just comes on. It's just like a phone, right? Like, there is no spinning circles, none of that. You open the screen and boom, it's right there. So the instant on is another huge sort of key attribute or value prop of Windows on ARM. So with that, let me sort of give you a little bit of why we did ARM. And for all of you, obviously, who are deeply tech enthusiasts here, you all have seen the Apple announcement, right? Like, obviously, Apple is going to ARM. So so this question is kind of a misnomer, but I think it's still valuable for me to address why Windows on ARM. Why add more mental tax on the developers, right? The developers already have to create x86, x64 packages of their apps. Why now create one more package on their app? And so if you think about purely from that perspective, like look at the number of devices that are there that are running on ARM. You have your phones, you have the IoT devices, billions of devices running on ARM today. And we've seen from Apple, we've seen from Samsung, the performance per watt of the ARM processor is pretty good. So really the question should not come as like, why is Windows 10 running on ARM? It should just be like, why shouldn't Windows 10 running on ARM, right? Like there is no reason for us not to run on ARM. And so that's sort of our take on this. And so when we use ARM, how are we sort of making and taking advantage of the ARM processor or the Qualcomm processor, right? ARM, to give you a little bit of technical deeper insight here, ARM has this, the processor on ARM, they have something called the big little architecture. The big little architecture really is the idea here is that you have two sets of processors. One runs at a higher frequency, one runs at a smaller frequency. But they're basically the same processor. So that means they're the same instruction set, everything is the same, they're interconnected, right? So that the threads can move between each of them easily, fast, and there is no memory caching kind of complexity. It's just, it's a uniform processor. However, because they're clocked differently, what that means is when you're running on the little processor, there is less power being consumed. Now, why is this interesting? This is interesting because now when we look at the Windows or how we schedule things on Windows, if you're using an app, that app is in your foreground, but you have tons of other processes running in the background. You got services, you got tons of other things going on. All of those things may not actually be required by you. And if they're not required by you because you're busy browsing the web, you're using Outlook, you're using PowerPoint, what we do is we try to take all of the background threads, all of the ancillary threads, all of the ancillary processes, and run them on the little core. So when you're running them on the little core, what that means is that they're actually consuming less power. However, the thing that you're using, the thing that's in the foreground, that is getting the big core. And so from an appearance perspective, it does not impact your perf at all. It does not impact your experience. However, because we can do this, we are actually getting much better battery life just when you're actively using the device. So that's one of the interesting key advantages that ARM provides. Smaller processor packet size. So the ARM is a mobile processor, as you all know, right? It's used in your phones. It's small. So that part is obvious. However, it's also a SoC. A SoC really just means like a system on a chip. What that means is that all of the things that you use are on part of the processor. So if your GPU, your sensors, right, they're all your memory, they're all built on top of the package, on the processor package. What that means is that it is way more power efficient because of that. Because the distances that the bits have to travel, because the process it's all built on the SoC, is much less. So the processor itself is way more power efficient. And the other interesting advantage is because this entire package is so small, when you put it in a PC, you can actually load it up with a bigger battery life. So the combination of a small processor and a big battery is pretty obvious. You'll get very good battery life when you have an ARM processor on a PC. And then same story with the LTE, right? The LTE is part of the SoC. There is no USB dongle on the side to get LTE. It is part of the SoC, and so it gives you innate power efficiency. Yes, if you want to use LTE, you get power efficiency. It's just like your phone. There is no special thing to attach, right? All of these gives you better power efficiency. And then because it's a mobile processor, it gives you instant on, right? Like just like a phone. Press the power button, it's on. There is no spinning circles. There is no waiting for things to happen. And so these are some of the key reasons that we think Windows 10 on ARM provides value. And this is actually what we are seeing from our customers as well. And inside the community, if you used it, obviously tell us about it. But this is what we are seeing in a user study as well. People are really appreciating these benefits.
And there's also one thing to add there is the small package allows our OEM partners to really create a very thin and light designs of the devices without fans, right? So there is no active cooling happening. So it just really allows our OEM partners to really innovate on how they go and build a very thin and light devices. And these are super thin and super light.
Yeah, exactly. We can talk about it a little. So how did we do this? I mean, it's pretty simple, right? We recompiled all of Windows to ARM64 instruction set. ARM64 is the ARMv8 instruction set, if you are curious, right? That's the technical instruction set. If you think back to Windows history, Windows NT, the kernel itself, has supported multiple processor, Alpha, MIPS, PowerPC, Itanium. So historically, our engineering systems is designed to handle multiple architectures. So we have a very clean layering where we have the kernel, we have a HAL, sort of the hardware abstraction layer, like all of the core code that talks to the hardware and the devices. They are abstracted such that the pure assembly code is in one directory, is in one part, and then the non-assembly code is another part. So for us, compiling Windows to a new architecture, while by no means easy, while by no means trivial, it's something we are used to. It's something we've done historically, like like if you read the history of NT, like Cutler and his team actually. Our team actually has we've always designed NT for multiple processor architectures, right? Windows is cross-platform by design is the key term here. And so what exactly did we do? If you think about Windows, there is really or any operating system for that matter, right? There are two pieces to it. There's a user mode, there's a kernel mode. The kernel mode is really where you have the drivers, where you're talking to the graphics, subsystem, the networking, the disk, all of the hardware. Like that's where you're talking to the hardware. All of those pieces we compiled for ARM64, right? Everything, the shell, edge, services, all of these have been compiled for ARM64. And so that's why when you use Windows 10 on ARM, actually the performance is really good because everything is running natively. Your browser, your shell, your entire OS is pure native, right? That's the advantage of, that's basically what we did. And so to show you some of this, I am going to give you a demo of the latest insider builds. And so at this point, I'm going to switch over to my machine. Actually, I'm not really switching over. I'm just going to show you my desktop onto Teams. So hold on for 1 minute. And I'm going to disconnect and can display my desktop. All right, you guys should hopefully see my desktop now. And so what I'm showing you here is something that is only available in the insider builds today. It is not available in our release RTM Windows 10 on ARM. This is the Windows hypervisor. We are running Hyper-V VMs on my actual Pro X device right here. And for the people who don't actually believe me that this is Pro X, just to belabor the point, I have an insider build and I'm messing with it. So that's why you don't see it. But this is an ARM machine that is running in Pro X. And let me show you the Hyper-V VM here. So given that this is an insider population, I wanted to show a little bit of developer-focused demos. And so what I'm going to show you is a developer tool called dtrace. This is an open source tool that is available for Linux, and now we supported it and ported it on Windows. So I'm going to show this running on ARM, right? And you can see that this is ARM. It's an ARM v8 Qualcomm, right? And so I'm going to show you how to run dtrace. You don't really have to learn a whole lot about what dtrace really does, but think of it like a way, it's an open source tool that allows you to debug and inspect the OS, inspect the kernel, inspect the stacks. And so what I'm going to show you is a very interesting, simple exercise. It's not really supposed to be complicated, but really what I'm showing is I'm going to launch Task Manager. And once I launch Task Manager, I'm going to profile Task Manager to show you what its threads are doing. And so here's where I launch Task Manager. And so I'm going to try and switch through multiple things. Yay, tab, startup, services. And so now when I close Task Manager, what you will see is a bunch of the topmost threads or sort of profile of what the threads are doing. And so what you're seeing is a stack trace here of all the user mode threads that Task Manager has and what they're doing. So it's pretty interesting. You basically are able to see what all Task Manager is doing while you just launch it. So I didn't do anything. This is pretty simple, right? So here's another way. I'm going to start Notepad, and you're actually going to see the kernel stacks. This is different from the previous one because what you saw here were user mode stacks. And now I'm going to show you the kernel stacks using the same tool with one minor change. And I will show you what the minor change is. I'm going to do some stupid things. Hello world, because obviously this is a computer science demo. So there you have. And then now it's showing you stacks in the kernel. As you can see, this for the people who are interested, you will see that the names are slightly different because these are more about the kernel. These are kernel components, this .sys drivers. And when you saw the task manager, you were seeing user mode DLL, so you will see .dll. If you noticed, doesn't matter. And then finally, one last demo I'm going to show you, and this is only possible because I'm running this in a VM. And the idea here is I am going to bug check this VM. And since I am doing this entire Teams demo on the same machine, it is actually showing a lot of confidence on my part that I'm going to bug check this VM, and hopefully it shouldn't go wrong. But if it goes wrong, you know what happened.
Yeah, I was about to say, if all of a sudden you disappear.
It feels a little overconfident that I'm doing a bug check demo while presenting from the same machine, but hear me out. It should be okay, I think. So sysinternals, Marcus has this tool called Not My Fault. It allows you to bug check the system. And since we have dtrace, we don't actually need Mark anymore. We can do a simple script to bug check the system. Don't tell Mark I said that.
He's probably watching live right now.
Oh my goodness.
All right, I'm hitting enter, and this should bug check the machine, the VM. There you have it. The VM was disconnected. I'm going to reconnect. You will see the blue screen of death. There it is, or the green screen.
It's green.
It's green, sorry. Yes.
Additional proof that it's an insider build, you know.
Yeah.
So that was my demo. I am now going to shut this down, and I'm going to go back to the slides. We only have a few more slides, so it shouldn't take too long.
I gotta say that was pretty gutsy for you to do that. I mean, it worked obviously. Yeah, it's nice when a plan comes together, but
I know that was a little foolhardy. I
am impressed. I am impressed.
Hey, we have our confidence in our hypervisor and our Hyper-V.
All right. You guys can see my slides again?
Yep.
All right. So let me talk about apps, right? At the end of the day, people use the PC not because just the PC, not for the PC itself, just also for the apps on the PC. And so how do we build apps for Windows? We released Windows 10 on ARM for the very first time around 2018. So when we first released Windows 10 on ARM, this was sort of the story. If you think about Windows, roughly the buckets of apps in Windows are, there's a UWP app, there's desktop Centennial apps, there's obviously Win32 desktop apps, or x86 and x64, and then you have drivers. And so when we first released, the only thing we had was we could run UWP apps in it. And this was very deliberate, but over time, like at 2 years ago at Build, we released Visual Studio ARM64 support in preview, and then that has now matured, and now Visual Studio supports ARM64 as a first-class citizen. And so what that means is any app you have on Windows, right, whether it's a UWP or a desktop Centennial app or a Win32 desktop app, can be ported to ARM64, right? That is the whole idea here. The whole idea here is that we want our customers, our developers, to port their apps to ARM64, because that is what really provides the best experience, utilizes the best power on this system, right? And so if you're a UWP app, there is one extra sauce or one extra sort of option in the middle there. And you also have the ability to run ARM32. So which it basically means that you can, if you're a UWP developer, you can do an ARM32 or an ARM64. The choice is completely up to you as the developer. It depends on you what you want, whether you want more memory of the 64-bit address space, or would you prefer the 32-bit address space, right? So the choice is completely yours. Both of them are fully supported by our tools, by our store, everything. And with that, I want to come to this section of the talk, which talks about x86 emulation. Until now, what we have talked about primarily is Windows 10 on ARM experience, the pure native ARM64 experience. How do we take our apps and recompile to ARM64? But what about if you don't have, you are not able to because maybe you don't have the code, or maybe you don't have the libraries right now to support, or maybe you just don't have the time right now to port something to ARM64. And so for that, we have the magic of x86 emulation. And so I will hand it over to Neeraj, who will talk about exactly what x86 emulation is, why we did it, and the magic of it. Take it away, Niraj. I'll
Yeah,
drive this.
thanks. Awesome. Thanks, Hari. So as Hari mentioned, we have all the tools in place with Visual Studio for developers to write code for ARM64 native, and that's the guidance that we do want our developers to actually write code for ARM64 so it runs native. But we do realize there is a large ecosystem of Win32 applications that are out there today for x86 instruction set. So we do want to make sure those applications continue to run on this platform, right? Because we want to provide choice to our developers and our users and make sure that on day one, when our users go and buy one of these devices, they are not blocked from having all the apps ported to ARM64 and they can just get going and run the apps that they're used to. So to that end, we created this x86 emulation layer. It's a built in-house, and it's a binary translator that dynamically translates x86 instruction over to ARM64. And it does it in a completely transparent manner to the user and developers. So as a user, you can install application like you normally do, right? Whether you go online to download an installer package or you go to the store and download an app from there, you install the app like you would normally do, and emulation is working in the background and just installing the app and also launching the app. So after you go through the installation, you'll see the app icon show up on your desktop, on your start page, and pretty much anywhere that you mention where you want your app to be installed. And you just launch like you would normally do on your Intel PC, and then the app will launch, and your x86 emulation will start, emulating that application. So when we talk about emulation and we talk about translation, there's always this question about performance overhead, right? Because anytime you go through any kind of translations or any kind of emulation, there is always going to be some performance overhead, and that's the reason why we are asking developers to write code for native for ARM64. But to kind of alleviate some of that performance concern, we have made optimizations in our Jira itself, and also we do some fancy things like we cache the code that we already translated, right? So if you think about it, when you have an x86 app running and we're translating that x86 instructions to ARM64, we go ahead and cache that translated instruction into the memory and disk. So the thing is, the next time you launch an application or the next time you hit the same code path, there is no reason to retranslate that piece of code. It's already been translated. So we go ahead and read that code directly from the memory and disk to kind of speed things up. And to speed things up even more further, we built this new technology called Chippy. It's a compile hybrid portable executable. And this is a co-engineering effort between us and our good friends who are in the compiler team in DevDiv to create this new technology that I'm going to talk about next. So before we get to the Chippy and how it works, next slide, Hari. I wanted to provide a little bit of a overview of how things work on this PC, right? So on the left side, you have your native process that Hari talked about, right? You have your Edge, Cortana, Shell. Everything has been ported to run as native, as ARM64. And then you have your native system binaries. These are your OS binaries, right, that we ship as part of the Windows OS. And these are also ported to ARM64. And then there are some special system binaries like NTDLL, right? These are the binaries that applications use to communicate with Windows kernel. And as Hari talked about earlier, Windows kernel and all the drivers that we ship in box are also ported to ARM64. And at the very bottom, you have your hardware layer, you have CPU, GPU, disk, networking, and all their sensors and things like that. So that is a pretty clean path, and we know what to expect there. On the right side, now you have x86 emulated process running. And this is where things get a little interesting, right? Because now you have two parts. The top part is your x86 program, for example, Photoshop, running under emulation. Now it also has x86 system binaries that I talked about. And these are also running as x86 under emulation. And then at the bottom, we have a native code. And this has a WoW abstraction layer. So this is the Windows on Windows abstraction layer that is pretty similar to what we ship today on Intel x64 machine that allows users to run x86 programs on x64 Intel, right?
So what happens on Intel machine is that the CPU is capable of running x86 instructions, right? So when CPU detects that, hey, I'm about to run x86 instruction, it switches the mode between x86 and x64, right? So x86 applications can run on x64 Intel processors. Now on ARM PC, we don't have that, right? So this WoW abstraction layer talks to our x86 emulator, and the emulator kicks in and starts translating x86 chunk over to ARM64 instructions. And then once the instruction has been translated to ARM64, it just runs as native speed. So you may wonder, gee, why do we have x86 system DLLs running under emulation, right? These are Windows code. Can we not run them natively? And there are a couple of reasons for that. One is if you are familiar with writing apps for Windows, you may know that if you have an x86 program, the x86 program is communicating with system binaries using x86 calling conventions, right? So that's the language that the application is speaking with the OS binaries. And the application is also expecting the data types to be 32-bit as well. So now, if we replace the x86 system DLLs with ARM64, the applications wouldn't know how to communicate with the ARM64 system DLL, right? They'll be talking to a different calling convention. So that's the reason. If you look at any, Windows on ARM devices, like for example, Surface Pro X, and if you go to like Windows directory, you'll see System32, right? You'll see syswal64, and your syswal64 directory actually has x86 system binaries, and those binaries are needed for the applications to run successfully. And but there are certain things that we can do to speed things along, right? Because these are the x86 system binaries that ship with Windows, so we have the source code for it. So this is where I talked about Chippy, which is compile hybrid portable executable. And the idea behind GP at a very high level is they're built from the same source space as this x86 system binaries. And the idea here is that this GP DLLs, inside the binary, they contain ARM64 instructions, but they have x86 calling convention, right? So think about it. If you have x86 application, like Photoshop, and when it tries to load a system binary, we go ahead and load a GP binary instead, right? And what this GP binary does, it exposes x86 calling convention. So for an application itself, it is just pretty much talking to any other x86 system binaries, right? Because it can communicate, to the x86 calling convention. But inside the binary, we go ahead and execute ARM64 instructions. So because of this neat trick, right, we can actually speed things along even faster. So with the bunch of GPDLLs getting loaded into the x86 process, the only thing that we are emulating, in a way, is only the x86 process, and everything else underneath is pretty much running as native. So these are some tricks that we use to speed things up. And when we talk about emulation and when we talk about translation, this performance is always going to be the question. So we tend to break the application into different buckets, right? So there are some applications that are very CPU intensive, right? These are the applications that spend a lot of time on CPU, right? They're doing a lot of calculations, and these are not common applications, right? But if there are applications that spend a lot of time on CPU, we expect the performance to be okay or good, right? But again, like I said, these are not common applications. No application spends all their time on just doing CPU operations, right? If you look at any application is doing like I/O stuff, GPU work, and when you have your typical application that is doing read-write memory, read-write disk, or doing GPU offloading, we expect performance to be good. So this is kind of like a high-level overview of how the native process runs on Windows on ARM and how the emulated process runs on ARM, and the expectation around the performance.
Awesome. So I think the key point here to keep in mind is even if you're emulated, it doesn't mean that all of your code is emulated. The point we're making is that a lot of the code, even though is not yours, a lot of the code will be in drivers or in Windows DLLs. And though that code will be native, either through Chippy or because they're in the drivers. And so even when you're running emulated, never assume that emulation just means it's always x86 code being emulated. It just means that a lot of the app code is emulated, but a lot of the system code can be running at native speed.
Right.
That I am going to cancel my presentation. Not cancel, I'm going to end my presentation, and then we will just open it up for free-form questions. Is that good, Jason? Or do you want me to keep the slides up?
No, we're good.
We're good? All right.
No, I was going to say there's definitely as I readjust here in my chair, there are definitely a litany of questions that we can cover. And there's been some interesting conversation in the actual chat as well. Yeah.
Hey, can I get a link? So that I can follow it. I actually haven't seen the Twitch stream, so I don't know what people are asking and are there. Oh, this guy sucks.
Hari, this is Brendan. So before we dig into the questions, I would love to know more about what kinds of Windows 10 ARM PCs are you using today? I mean, naturally we talk a lot about the Surface Pro X, but I'd love to hear more about what you use.
I am I use mostly ARM devices. I am all ARM all the time. And so I use two devices, primarily Surface Pro X and the Samsung Galaxy Book S. So this is a pretty new device, and I have to admit I am more than partial. I primarily use the Samsung Galaxy Book S because I like the form factor more than
so
the
thin.
Pro X.
Yeah.
Hopefully Thanos doesn't fire me when he hears this, but that's sort of what I use. But there's also other devices coming, and I believe Qualcomm has announced a few of those devices at their IFA recently, and so there's a lot of action in this space.
And I think Lenovo also announced their Yoga 5G device earlier this year, and that's the first 5G device in the PC segment, as far as I'm aware, and that's also very exciting news. And all these devices are super thin and light. If you look at the Samsung device that Hari was holding, it's incredible how thin it is.
Right, it's super light. Like even though it's a laptop form factor, you won't even if you would lift it, it's super light. I think your cat's heavier, Jen.
Probably is.
My cat's about 10 pounds. So.
Yes, you could have a couple of those Samsungs, Samsung and a Surface Pro X, and your cat's still like tipping the scale.
Probably 10 of those, 10 Surface devices.
So real quick, Hari, I did drop a link in the chat, but if you want me to just tell you, it's twitch.tv/Windows Insider. When you do bring it up, like we were mentioning earlier, do mute the stream so the audio doesn't feedback. But other than that, you should be okay. There's a ton of questions. If you have trouble seeing, I think it will show you the historical chat when you load in. If it doesn't, I'm happy to go back and pull some of the questions out from there. So
that I can see the history on the chat.
Okay. All right.
Which is true. It's fine.
Okay.
It's fine. You're good.
We'll make it happen, right? Yeah. And so I'm just going to, at least out of the chat, we'll tackle some of those first for the folks that are here with us live. Again, if I happen to ask a question, because I promise, I love ARM, right? I love the Samsung device that I have, but I am not the expert on things we should or shouldn't talk about. So if I ask a question that we can't answer, you know the drill, right? Okay. Let's see here. There was a bunch of questions, so it's gonna take me a minute to scroll back up because I want to make sure I cover as many of them as we can. We did. It's like the first half hour, 40 minutes of the webcast was covering materials and doing intros, and we actually saved the rest of it because we got so many pre-submitted questions. So we will absolutely get to those. I do want to kind of defer to some of those that are live in chat. Thank you to everybody who joined us live for the broadcast. Really appreciate it. Okay, let me pinpoint some of these. I'm literally having to read the entire log here. So there was a question about you translate on a machine code level. Why not disassemble and recompile the base?
Sorry, can you repeat the question?
Yeah. So maybe there's something else I need to add here to the context. It says you translate on a machine code level. Why not a disassemble and recompile base?
You can't recompile because you don't have the source. So the only thing you could do is anytime you're translating, whether it's us or Apple, what we're doing is we're taking existing code that has already been compiled, and you have to disassemble it. You have to read its function. You have to read its code pages, and you have to translate the code pages. Recompiling basically means you have the source for it, and we don't have the source for it at runtime. We have the app. The app's already been built. It's already been installed, and so there is no source to do that.
Yeah. Plus, I think if you disassemble a function and then you recompile that function, right, you end up with ARM64 instructions already, right? So why go through that additional hop, right? When you're already translating and ending up with ARM x86 instructions, and when you translate that, you end up with ARM64 instructions. So we do have a JIT, which is just-in-time compiler, and that's what's pretty much what it's doing in the background, is taking the x86 chunk of code and translating and compiling into ARM64 instructions.
Awesome. And looks like the user replied back, I meant decompile and recompile, but I get it. So awesome. Thank you for tackling that one. Let's see here. There's another question. Are there any plans to add support to WinGet for ARM64 apps? That would be super helpful for rebuilding systems.
That'd be up to the WinGet team.
Yeah, and
there's probably a GitHub issue for it. Oh, sorry. Right.
Yeah, sorry. And please file user requests. I mean, at the end of the day, from our perspective, it's just a PC. If there's a functionality you use that is not available, file a request, and we will make sure it's supported. I can't make promises, but our goal is it's just a PC.
Yeah, and I'll take a moment to actually kind of bucket many of the questions that came in. Not an oversized proportion of them, but in the pre-submitted questions, there were several asks for when is this particular app or that app going to be supported, things of that nature. And obviously, there is a little bit of work, as you know, you mentioned in some of the discussion for developers to go through. And there's the difference between what I would consider like the internal Microsoft apps versus the external third-party applications that would require that. I mean, it's really the same work in both scenarios, right? Trying to make the conversion over. So I will kind of sum up some of those questions into kind of a more generic question. We've seen some of the apps get migrated without trying to commit to timelines or anything, because I know that we can't. Right. Is there kind of a longer term roadmap of hopefully trying to bring more along for the ride? I guess is a simple way of asking the question.
I mean, you've seen us. We are committed to Windows 10 on ARM, right? Like, we've been on the journey for a few years. Surface has released a device, Samsung, Lenovo, all of the big names are releasing devices. So we are committed to this platform, and we will keep innovating on this platform. At the end of the day, as I said, this is just Windows 10. And so if we are seeing actual gaps where, hey, this feature does not exist, that feature does not exist, it is just a matter of prioritizing and doing that work. So if you are inside the community who are actually our most sort of vocal community, like if you notice gaps that you think can make this better, like file the request, right? Like that is the best way to affect change here. Absolutely. Yeah. Like, we are all invested, and we are in. We are not. This is not we are in for the long haul.
Right. The demo that Hari showed, it wasn't possible like a year ago, right? But that's the work that we have done to enable hypervisor, Hyper-V, dtrace, all of those things are ported to ARM64 to continue to push this platform forward.
And it takes time, right? Like, to be honest, it takes time. Like, this is not it is an engineering cost. Like, I would love to do this, and like everything is there, but like that is not the reality of the world. Like, everybody has work to do. They have competing priorities. They have WinGet has like a bunch of own feature requests. Also, everything has to be has to be prioritized and balanced. And so we are committed, as I said, and if you're noticing gaps, please file a feedback request because that is the best way to get them addressed.
Yep. And so that actually leads to one of the pre-submitted questions was obviously Hyper-V. The question came in of, are we going to backport it to 20H2?
We backported a lot of the WSL work, so I can't say never, but some of the things do end up requiring quite invasive changes, and so we don't like to backport things unless there's a significant value that accrues to customers, right? And so in this particular case, we have no plans of backporting it, but hey, as I said, file a feedback request if you want. So
yeah,
that's right. Never say never, right?
Yeah. I mean, just kind of as a general note, obviously we get asked to backport multiple things kind of all across the broader Windows spectrum. Something will show up in a dev channel build and be like, oh, can I get this in beta or channel or the release preview channel? Things like that. And I mean, just as there is with any particular release cadence that we're working on, at some point there kind of has to be a defining line of, this is the scope of work that we'll be working on in a particular release and things of like that nature. So, obviously I'm not going to contradict anything that you just said, but like I would simply support the fact that I wouldn't expect to see it show up in 20H2.
Yes, we have. Yeah, exactly. Like we don't have plans, to be clear.
Yeah.
File it and we will evaluate it. But there's again the engineering realities. Like the backport is not, especially for core technical hardcore areas like hypervisor, right? Like it's not easy for us to move them.
Yep. Another one from the live chat a little earlier in the stream. So there's x86 emulation. Is this able to run x86 apps repackaged with the MSIX packaging tool on ARM64?
Yeah, so we do support MSIX packaging tool on ARM64. So even if you have an x86 program, you can package it as MSIX, or you can actually, if you run it or if you port it as ARM64, you can package it as ARM64 MSIX.
Awesome. This next question, it's one of those that was probably a little bit better if I had kind of jumped in the middle of the conversation when we were going through some of the presentation, but I'll ask it now. Hopefully it's not too far out of context. When we were talking about the drivers and DLLs and all that earlier, this question came in. So the system x86 DLLs are actually ARM64 code with an x86 call time interface? ?
Yeah,
so I think
it's different. We do have pure x86 DLLs and we have chippy DLLs. They are in two different directories. And the chippy DLLs, as Neeraj was saying, are actually, they are ARM code pages, but they are wrapped by x86 calling conventions because they are loaded in an x86 process. This is a little bit complicated, but the idea is if your process is x86, it can only load x86 DLLs or binaries. If your process is ARM64, it can only load ARM64 DLLs and binaries. That's just the reality of how Windows is built. And so the idea that the thing that Neeraj was pointing out was with Chippy, we have tons of our own code, right? You got kernel 32, you got shell 32, you got all of these DLLs that we own. We have the source code for it. It doesn't make sense for us to run those DLLs unmodified, untouched, fully under emulation, because as I mentioned, emulation is ideal when we don't have the source code, but we have the source for all of these DLLs. And so we invented Chippy. And so Chippy basically takes all of our code and then transfers it in this format where they generate ARM64 code, wrap them with x86 calling conventions so that they can run in apps.
Awesome.
That's the idea.
As I continue, I'm trying to scroll back to the most recent stuff to see if there's any other more recent questions.
Jason, there was a good one on feedback just a couple of seconds ago, or a couple minutes ago, I think.
Go ahead and read it in. What is it?
Yeah, it says, can Windows insiders post suggestions and problems as feedbacks in the feedback hub? And then also, can they submit suggestions, what they'd like to see on ARM devices, even if they don't have one?
Absolutely.
Yeah.
Yeah,
Yes.
use the feedback hub to submit like bugs, suggestions. Like I think if you launch a feedback hub, it'll ask you if you're submitting a problem or a suggestion. All feedback is welcome. So
Yeah.
feel free to send us feedback.
Yeah, I mean,
Yeah,
go ahead, Jen.
I was going to say at the feedback hub, I mean, it doesn't currently, like, feedback isn't split up by if you're running an ARM device or not. So you can file feedback on whatever you'd like. And I guess if you're reporting a problem on an ARM64 device, but you're not for an ARM64 device, but you're not running the ARM64 device, well, then we might have some issues where it's like,
Sure.
well, it makes it harder to, to analyze the traces of what's going on if you're not logging it on the impacted
And
device.
I think the request was he wants to suggest, or she, I don't know who, they want to suggest features on ARM64, but may not have ARM64.
Yeah.
But the bugs will be on the ARM64 machine.
Yeah, that's always been a challenge.
Yeah, and that's one of the
Yeah.
interesting things, and I'm gonna digress to smidge, but I promise I won't go too far off track.
And we do it
It's-
with every webcast, so.
I know. I'm just staying true to character here. There's this concept of I think in the commercial space it's referred to as a potential adoption blocker, right? There's some feature or functionality that either a individual user or potentially a company or something that they really need to exist that would enable them to make either a smooth migration or just some core functionality they're really looking for to enable whatever their particular use cases are. And so if there is something that you would consider a potential adoption blocker from you attempting to purchase or give the ARM environment a try on Windows, please do share that feedback. It's things like that that'll help drive some of the future of where the investments land, because the more of those kind of those roadblocks that we can overcome, the broader adoption we'll see on this platform. And so it's all good things. There's nothing but good things to come from that. So please do take the time to share it with us, and we're happy to look into it.
Someone asked how to file kernel feedback. I don't think the kernel has a node in the feedback hub. Like probably, I mean, you log it either for whatever's impacted or under the, there's a developer node, and there's just like desktop environment, all other issues, which my team owns, and we help like field it to the right people who should investigate.
Responding to a couple things here real quick. Next up on the list here, there's so many questions here. I'm just gonna have to like pick one. How's the performance of a Windows on ARM device when it's opted into the Canary channel internally?
Hey, I am using super like nightly build, so everything you saw is from a local nightly build, so I am far ahead of most of you guys. So it is as good as you would expect on a build.
I have my Surface Pro X also on Canary, but I mean it's very similar to Dev Channel. Like I just get builds a few days sooner to make sure that hey, if there's any issues, we want to document them and rel note them to insiders, etc. Because we do know that. There's a lot of insiders who have ARM devices. So like I do that on my machine just to make sure that we're catching things and not breaking stuff and whatnot. And it's fun.
Yeah, if you just get more frequent builds, that's all.
Yeah. That's pretty much it. I mean, and we're just it's for me, it's really trying to catch anything that might be a gotcha, so that way Jeremy doesn't get mad if we don't note something.
I would say though transparently, like I mean, the whole idea of insider community is we do end up sometimes releasing bugs, and I'm not trying to say we don't have bugs, and so
yeah,
you might hit something.
Oh yeah, and we and I'm not saying we want everything to be perfect in the dev channel. It's more just for me, it's about catching. It's just about catching things that are relevant to say, hey, you may experience this issue.
Yeah. And we have a discussion where like, is this bug, should this block the flight? Should this delay the flight? Should we rel note it? Can we do a targeting adjustment? So
for ARM, a lot of it isn't necessarily blocking, but we might blocking the flight itself, but we might block releasing it to ARM devices, which we've done in the
Yeah,
past.
I just meant general bugs, not
Yeah,
ARMs.
and which is, I think something that we we're mindful of. We don't like doing it, but we also don't want to put people in a bad state.
Right.
So Jason is stepping away for a bit, so he wants me to jump in with some questions.
You still have the huge list, right? The pre-submitted ones.
I am looking. I'm opening it up, and I am looking at the questions right now, and I guess I am supposed to pick.
Yeah. Sorry for putting you on the spot, Brandon. I do need to step away for just a moment. I'll be back as quickly as I can.
Yeah, no worries. I mean, Hari, can you talk a little bit about, can you talk a little bit about, when we talk about Windows on ARM and how it relates to like a Raspberry Pi? We've gotten a lot of questions in both pre-selected questions that were submitted earlier, as well as those in the chat, and people asking questions as it relates to Raspberry Pis and IoT. Can you talk a little bit more about that?
So the Windows 10 on ARM PCs are designed primarily for the Qualcomm Snapdragon processor. So that's what sort of the Windows client SKU supports, and that's the only processor we support. Windows IoT has a version that may run on other processors, and that may support Pi. I am actually not sure if it does. I don't know if you know that, but
It's not officially supported, but you can run Windows IoT Core on Raspberry Pi 4, and IoT also supports like Snapdragon 850 and NXP processors.
Right, but from our perspective, the PC or the client itself only supports the Qualcomm Snapdragon processors that we sell, so OEM sell devices for.
Jeremy just asked, if we're done with this question, Jeremy just asked a really good question in the chat as well. He said, what can be done for those who don't have ARM64 devices who need to develop for them? Is there any possibility for a Hyper-V that emulates ARM64 or something similar for those who only have x64 devices?
Yeah, that has proven to be a tough nut to crack. That is a definite blocker for developers. The problem with that is the hypervisor, as we design it, as we build it, is not a cross-architecture hypervisor. What that means is if you have an x64 machine, you can only virtualize x64 instructions. So you cannot run an ARM VM on x64. That's not how we do it. And so that means people who are building for ARM have to use an ARM machine, which is problematic. And we're looking into what we can do, but really, unfortunately, that is the only answer we have right now. You need an ARM device to test and build it. The one thing I would point out, though, is in our experience, if you're a UWP developer, most of the time the UWP app just works, right? Like if it works on x64 or x86, it just works on ARM64. Even if your desktop app, what we've seen is most of the time it just works. People who have basic code as non-assembly code, not just C++, Python, whatever, right? Like all of that just works. It's only when you have assembly code that's when things get really interesting, and you have to understand, because you might have SIMD instructions or like x86 assembly. You have to write them to the equivalent ARM instruction, the neon set. And so those are kinds of things you need to think about. But if you don't have any assembly code and you have all of the code, what we have seen is that most of the times it just works. But I think Jeremy's point is valid, and that's time. I mean, I'm just trying to paint a wider picture.
All right,
Got another one, Brandon?
Let me look. I am looking at the questions. Are we doing any work to support any other processor vendors available, like in additional to Qualcomm, other processor vendors for Windows on ARM devices?
No, Windows on ARM devices currently only support Qualcomm Snapdragon.
Qualcomm.
Yeah.
I have one question here, which I'm a little confused over about OneDrive on ARM for Windows, and I have OneDrive working on my Surface Pro X. Hari, do you like?
What's the question?
The question is, will we ever see a OneDrive on ARM for Windows? And
I wonder if they're asking. OneDrive today has this dual architecture on ARM, where the service part of the service is x86, and part of the service is ARM. The ones that interface with the driver portion of the Cloud Sync files, and so that maybe he's or she's hinting at that. I'm not sure. But OneDrive is available for Windows 10 on ARM. Like you can use OneDrive. I use OneDrive every day, so it is available. The process just has a dual architecture. That's all.
All right. Let's see here. Why aren't all Microsoft apps compiled natively for ARM?
I think this goes back to our original earlier question. We, Microsoft, are obviously committed to Windows 10 on ARM.
Yeah.
It's just a PC, and if you see gaps, let us know so that we can evaluate, prioritize, and push them. Right? Like, that is the truth, and the honest answer is all I can give. Right? Like, it is just a PC. We aim to get most of them on ARM, but if they're there, they can always be gaps just because of resourcing and prioritization.
And is the goal to get it to where we with the ARM the 32 the emulation stuff that we talked about earlier, is the goal really to get it so that performs just as well as native ARM apps compiled for ARM? Like if I have an app that I install and it's running in the emulation stuff that you discussed earlier on here on the webcast, is the goal for that to just be seamless and for the user not to really see a difference?
I mean, that is certainly the goal, but if you think about it, I don't think we will meet that goal. Like, think about it like you're translating, right? If you're speaking in English and the other person can only understand French, there is going to be some lag, but you saying English words and getting that translated to French. And so just the physics of it means that they will never be on par with native. Like, that's just not how it is.
Right.
And so what we are trying to do is we're trying to do a whole bunch of other techniques such that when it does fall into the native subsystem, into the graphics, into the into our code, we run it natively so that we can at least give the appearance of giving you on par with native perf or giving you very good experience. But if you take a stop clock and you're like, oh my God, I'm going to time exactly how much time is spent in the CPU, we can't hide it. Like, it's just the physics of it. The physics is the physics, right? You're speaking in English, you have to translate that into French. Like, that's just going to take time. There is no magic to it.
And we did get some questions about flighting on ARM devices. I know we've covered this a little bit earlier, but one of the questions is on the ARM devices that are available, they can be flighted with the Windows Insider program today, correct?
Yeah, you can sign up for Windows Insider program today.
And they get the same builds just like we normally do when we flight. There's no timing difference. And I know the answer to this, but I'm facilitating the questions for the discussion.
No, there's no difference. Yeah, it's the same as the rest.
Unless we find like a last minute blocking bug that we were talking about earlier, that we may have to hold back an ARM version, right? But that's not a common scenario.
Yeah. I am looking through these questions and I'm trying to figure out which ones that.
There is one interesting one, Brandon, if you want me to bring that up.
Go for it. If you see something in the chat now, like, this is
from the pre-compile question. One question is about, you don't speak enough about Windows on ARM. Why is that? So it seems like we need to do this more often, Hari.
Hey, anytime, call us back.
I was feels. I mean, it feels kind of similar. You know, sometimes you see those articles written, which is like 10 secret hotkeys on Windows, and I'm like, I don't necessarily feel that the
Yes.
emoji picker is a secret.
Yes.
But, you know, like with any of our channels, you have to be paying attention and maybe connected at the point at which we share the information.
Yeah. I mean, the honest truth is Windows is big, Microsoft is big. We have a lot of stuff going on. And so it's not possible for everybody to get equal coverage all the time. And so it's just sometimes some things are talked about, other things are not talked about. And so, like, yeah.
I know that.
Yeah, sorry.
Oh, I was going to say, I know that there was also a question that Jeremy had a couple, like, he actually sent it to me last week about the VHDX files for running Windows and Hyper-V on ARM. We are looking to update the VHDX files so that you can run a newer build in Hyper-V on your ARM devices, and we're working on getting that updated soon. It won't be this week, but hopefully next or the week after. Another question I see in the that was submitted is questions regarding Windows Server and ARM. Is there anything you can say about that?
No, we have no plans of releasing Windows Server on ARM.
Okay. So I'm running out of questions here, but there's another question where I don't quite understand it, but the question is, will Windows on ARM try to completely remove directly executable Win32 programs by hiding them from the start menu? I'm not sure why we would do that, but it's a question we got. I don't think we are going to do that, but
no, I mean, I don't think so. I don't know if I understood the question fully. But
Yeah, I don't think I understood the question, but
it seems weird why we would do that. I haven't been looking in the chat. Are there any other questions in the chat, Jen, that might be worth bringing up?
There was one about C#. Someone asking if C# developers have to do anything special in order to make their stuff work on ARM, or is it just a matter of switching the compiler to ARM?
That's a good question. I don't know who asked, but for .NET developers especially, to run natively on ARM, you need to use the .NET Core, sort of the .NET 5.0 standard, and not the .NET Desktop. So if you target to .NET Core, that will run natively on ARM. And if you cannot target to .NET Core, you will have to run as an emulated .NET app. So there is an extra leg of effort, but it's the same as recompiling, right? If you're recompiling, they want us to we want you to recompile to .NET Core.
Can you talk about the differences between what was called Windows 8.1 RT and Windows 10 as it relates to the ARM platform? Or is Windows 10 just a natural evolution that just incorporates all of that?
Windows 10 is just Windows 10, right? Like when we did Windows RT, that was a slightly, or not slightly, or largely different SKU, and it was designed at a very different system. Surface RT was an ARM32 processor. The current class of Windows 10 on ARM devices are 64-bit processors, so they're all future-looking and they're 64-bit and they run 64-bit code, whereas RT was a 32-bit processor and ran 32-bit code. But from our perspective, the Windows 10 on ARM is just Windows 10. It has no relationship to Surface RT or Windows RT, sorry.
And it builds from the same code base. We have home, professional, enterprise SKUs, just like you would expect on Windows.
Right. Exactly. We're all working in the same directory. The same directory just spits out 3 different executables.
And then we also have, I get this question quite a bit as well, but there's questions about why we don't release ISOs for ARM. Can you talk a little bit about that rather than because I know that we don't, and instead for like Hyper-V, we don't release the ISOs that people can mount and install, clean install of Windows. We do the VHDX. Can you kind of talk a little bit about that?
Yeah, we can talk about that. It's an interesting question. ARM is not like Intel in the sense that you can take a clean ISO and try to boot into it, because you also need the firmware of the processor to match it. And so that's why we don't give you clean ISOs, because if we give you clean ISOs, it may not just boot into the system.
Yeah.
It has to match the firmware that is installed on your actual device. And so that's why we prefer to give out VHD files, because then it only loads it in our hypervisor and we can make sure it boots. Having a clean ISO may not just boot on a regular on your Pro X or your Samsung device. That's the main reason. So we don't want to create more troubles for customers, because some people might take the ISO and think, hey, it's just like I just boot into it, and it may just
they'll run into issues, and it's better not to provide it.
Right, because there may be a handful of users who will be like, no, I'm technical enough, I'll figure it out, I'll fix it, which is probably true enough, right? Like we know Windows is super technical, but we also have to address the vast majority of the people who may end up running into problems.
We just got another question, which is, will we be able to provision ARM computers with tools like SCCM or MDT?
Niraj, you want to take that?
Yeah, we do support like a modern management on these devices. So Autopilot is supported. IT can use Autopilot to deploy these devices, and you can use Intune and MDM solutions to manage these devices. All the way from anything that you can do with Autopilot and Intune on your Intel systems, you can do it on ARM64 system. You can deploy applications, you can run scripts. One interesting thing about ARM devices is also you can use Intune and MDM to also configure your firmware. So we have that ability as well. So you can actually, as an IT admin, you can, modify the BCD settings or boot settings, all the way down to firmware.
I would also point out that all of us who are on this call, we self-host ARM devices. These are all domain joined. These are all MDM joined. All of the fancy IT policies that you guys think you need are used in double amounts by our IT. So,
oh yeah.
Yep. Our devices are super managed,
including ARM devices. That's right.
I came back on at a really interesting point in this conversation. Hey, I will just say real quick, obviously that is not normal for me during a webcast to have to step out like that. I just want to apologize not only to you, everybody who's here, Brandon, Jen, Niraj, Hari, Eddie, and then of course to all the folks out there in the audience dealing with a little bit of a follow-on from a little home emergency scenario. Nobody's dead or dying or whatever, just a quick bit of business I needed to take care of. So my sincere apologies for stepping out. Thank you for bearing with me. Brandon, I appreciate you going and continuing the questions. It sounds like it's been some interesting conversation, and I'm curious to hear what question you intend to ask next.
Well, I'm running out of questions in the pre-selected ones to ask, but I mean, now we're getting into kind of like the nitty-gritties of some, like when are we going to get a send to OneNote printer driver for Windows on ARM? Things like that. Though, there are people who are asking. There seems to be a theme of questions on the status of the work going to create parity between going from an Intel-based machine to an ARM-based machine and getting the same experiences. I don't know. I know we've covered bits and pieces of that throughout the webcast, but I don't know, Hari, do you want to tackle that a little bit? I know that I know we've talked about it being a journey, right? And we're continuing to iterate and add new functionality and improvements over time. But that was a question that someone did ask, like, hey, I need a OneNote printer driver so I can send stuff to, print to OneNote.
I actually feel like that should already work, but maybe it doesn't work on this person's device, because I do end up using that functionality a lot. So, but I mean, please file a bug if you do. Like, exactly the point, right? Like, if something is not working that you think should work, and please file a feedback bug, because at the end of the day, as I said, it is just a PC. It's Windows 10 on ARM. We are not like trying to make this some special thing, right? Like if you use something in your daily lives and it doesn't work on your ARM PC, please file a bug. There is no other answer from my side.
Can you talk a little bit more about specific software that have been modified or compiled to be full, like to take advantage of ARM? I know that over the last couple months, I know that Visual Studio Code is now natively ARM. Chromium Edge also now has a native ARM version. Can you talk a little bit more about some other pieces of software that people can install on their ARM PCs that truly kind of take advantage of the platform?
I personally use Firefox a lot. Firefox is native. I use WSL a lot. That's native, right? Like those are some of the two of my most common used third-party apps. Niraj, if you have any more, chime in.
Yeah, I mean the store has more ARM64 and ARM32 apps like Netflix, Hulu. All those applications are native on this platform. And I think Java is also ported to ARM64. So if you have command line Java applications, you can also run them native.
We recently announced actually a blog post where our team in the compiler team, Java team in the developer division actually ported Java for ARM64. So we had a blog post on that. And then if you just go back a couple of years ago, right, like our team, we ported Chromium to ARM64. We also enabled LLVM on ARM64. The reason we did these two are sort of, if you look at the bigger picture, those are how you enable a whole swath of the ecosystem, right? Chromium leads to obviously Electron, Node.js, those kinds of things. All of them are native now because once we got Chromium, Electron, Node.js went native. LLVM is another hugely popular compiler for the open source world, and so we helped. We worked with Qualcomm actually to enable LLVM to support Windows on ARM ABI. ABI is like application binary interface. Basically, so that if you use LLVM, you can generate ARM64 code. And the reason we did LLVM is because a lot of the browsers like Chromium and Firefox, they use LLVM to recompile. So you need the compiler to support the architecture so that the apps can and the middle layer or the middleware can then build themselves. And then once you have the middleware building themselves, then you have the apps who build on top of the middle layer. So it takes time, right? It's a pyramid. It just you get the compiler first, then you get the middle layer, and then you get the apps. It's just a journey. But these are some of the big names we've helped personally to port to ARM64.
I think I found the Java blog post and I put it in the chat for what it's worth. But awesome. We did get another question, which was like, are there any challenges that are top of mind for you right now that you'd like to work on addressing with ARM?
I personally think the challenges for me that are top of mind are the third-party code, open source or otherwise, right? Like a lot of people rely on libraries that they don't author. People who write apps, they end up using a lot of third-party DLLs or OpenSL or this auth library or that thing or this thing. And that is where, or no, this NuGet package, that is what we need support for to port to ARM, because people may be willing to port to ARM, but if they rely on a library that they don't actually author, they don't want to port until that library comes along. So I think that would be my number one key ask. So if the developers in the insider community, please try and port to ARM. And if you hit issues, like reach out to us, we are very willing to help.
And if someone finds an app doesn't work on an ARM device, are we tracking requests for apps? Are we tracking that through like Feedback Hub? Like I could go in and like, hey, GitHub desktop doesn't run on ARM. Can I, put that in Feedback Hub, and then your team looks at that, and because you guys have a good deal of people who are reaching out to app developers based off of those requests to work with them and try to enable them to get supported on ARM, right?
Absolutely. We have, Neeraj can talk more. We have a GitHub entry for x86 apps on ARM actually, so that if you run anything emulated and it's not working, like that is the entry to file the feedback, because that's what we're monitoring. And then if you just have a feature request, hey, this app needs an ARM 64 version, the x86 version works fine, but I want a native version, right? Like this is file the feedback request.
Yeah.
Yeah, absolutely. Yeah. Like, if you have any suggestions on apps that we should go and try to get them ported, feel free to let us know for sure.
Well,
You said you
I'm
tracked
not-
that in GitHub? Oh, sorry.
Oh, I was just gonna. No, I was saying I brought up GitHub Desktop because I'm not as intertwined in the command line functionality of syncing GitHub repositories, and so GitHub Desktop does it with the visual front end, and so I need that on and it won't install on my ARM PC, and so I've been submitting feedback just like a normal customer would, saying, hey, this doesn't run on my ARM device, and I'm just as curious as others are about how your team works to field those questions, track which ones are getting a lot of feedback on, and working with those like maybe not just internal Microsoft folks, but even third parties on, hey, let's do some work here so we can get you on, running great on ARM.
Yeah, no, we have an actual feedback hub entry called x86 apps on ARM 64, and so that will be the entry to use when you run into issues where apps don't work.
There's a node in Feedback Hub. Yep.
I'm going to do that right now.
And if you have an x86 app crashing for some reason, you can use the same node to collect the traces and file a bug, and the bug will get routed directly to our team.
Exactly.
Oh, so that node's already set up to pull the right logs.
Yeah.
That's awesome. Okay.
Yeah.
Is that
That's
is that
cool.
under developer platform? Or is that under apps?
I think it's under apps.
I'm pulling up feedback hub right now. I'll try to post something.
While you're doing that, Brandon.
It is under apps.
Okay, good.
Sorry.
All right. Thanks, man.
Brandon, did you happen to ask the question relating to, interestingly enough, like, never mind. I'm going to change that question. I actually misread the question that had been submitted. There is a question on here about releasing the equivalent of like ISOs for ARM related builds. So I do have an AKA link that I'm going to drop into the chat. It's aka.ms/whiparmvhdx, and you can visit that page. Okay.
Yeah, we covered the ISO situation and why we don't release ISOs and why we do VHDXs. And then we also covered that we are intending to release an updated VHDX for a newer build in the next coming weeks.
Awesome. Again, sorry, I missed.
No,
you're good.
It's a good question to reinforce, because I know that after talking a lot about the Hyper-V functionality in ARM, people rely on those VHDX files. So it is definitely top of mind for me to get updated so that insiders have the newer builds to run in Hyper-V on their machines.
Quick time check, guys. We got about 4 minutes to wrap things up here. So I don't know if anyone has any final words. Hari, have you got anything you want to just share or close up with?
No, this has been awesome. The insider community for ARM is small, no doubt about it, but it's generally very vocal and very supportive. I think in general, the insider community is super supportive. So thank you for your help and support. And we are listening, as I said, right? Like, you're always listening. Our feedback if you need something.
Awesome. Nirav, anything?
No, for sure. Thank you, to everyone in the Windows Insider community to, help us make this product better. And as we covered earlier, you may find some features working, not supported, apps not supported. Please let us know. We are listening, and any feedback is a good feedback. So, yeah.
Yeah, I won't do my usual kind of feedback monologue that I had seemed to do each webcast. No doubt it's been well covered, right? Even in the time that I was listening in after returning. I just have to say, number one, I really appreciate both of you making the time to come and join us. The presentation material is always super helpful. I know that I'm a visual learner, so seeing some of this stuff, it sinks in a bit better for me rather than just hearing a talk where it can kind of come across like Charlie Brown's teacher sometimes.
I was actually nervous about doing the presentation, Jason. that I might come across like, oh, dude, this guy's giving a talk, and like,
No. No. I mean, I think talking through it helps people that have that learning style, and then the visual side of it, which is why I always encourage guests who come onto the webcast to actually do some of that, because I mean, hopefully I'm at least a small representative for some of the population out there that like seeing things. It helps stick better in my head at least. But again, really appreciate you making the time. I can't thank you enough. As you mentioned, the insider community that loves ARM. Vocal is one way to put it. Passionate's another. There's many other words that I could use there, but I want to make sure they're all super positive, because really it's just dedication and the desire to see the platform succeed. So for the number of years that you've put into it, your love, time, and effort, your professional career. I mean, this is what you are working on day in and day out. There's a lot of heart and soul that goes into it, and it means a lot to stay dedicated. And then for you to come and take the time to share with this audience and hopefully beyond, because I know you do more than just the insider community. I mean, going to the tech talks and doing presentations and everything. So it's great to continue getting the word out. ARM's not going anywhere. We love it. Obviously, we're invested in it. There's more to come. I won't get myself or anybody else in trouble. There's always something new to come, so stay tuned. I will simply say that. Hopefully that's an easy enough statement. But I realize I'm probably rambling a little bit here, but I'll just say thank you once again. I really, really appreciate it. Hopefully the insiders appreciate it as well. If there are any other questions from the chat that users don't think we got to well enough or whatnot, you can always post it in the answers forum, post it out on social. I did out on Twitter share your Twitter handle, but I'll drop it here in chat again in just a moment. You can tweet to Hari directly, or you can tweet to myself, Brandon, Jen, any of us, and of course we'll always help make those connections. The real Hari P. There we go. I got the link. Let me get
yes.
that. Wait,
Don't be fooled by those imposters.
Yes.
I tell you, man, there are so many Hari Pulapaka out there trying to be Hari Pulapaka. You gotta be, we found the real one here. So.
Oh my goodness. That's why I love these webcasts. They're so much fun. All right, I finally got that dropped in chat. Unless there's any final words, Brandon, Jen.
I love Windows on ARM. I mean, I love my Surface Pro X. Windows on ARM changes the way that I work, and to being super mobile. Like I could go and work from anywhere because I have the mobile broadband built in. I have all day battery life, which is just bonkers. The performance is great. I can use it to do all of my handwriting notes in OneNote. It really I don't have to worry about wherever. Like I could go someplace. And even if I'm out on one of my very famous Brandon drives on the middle of nowhere, most of the time, if I need to get online, I could just take my device out. It's right there instantaneously. Log in, and boom, I am online, and I can respond to emails. I could do everything that I normally can, sitting at a PC connected to wireless someplace. And so that mobility, I think, for me has been truly amazing to see. And so I'm really excited to see what else happens with the platform going forward.
Well, now you have to choose between your Duo and your Pro X.
Oh,
they work great together.
I know.
Exactly.
They work great together.
So on brand, Brandon. So on brand.
I mean, I can do a lot of it on my Duo too, and I use remote desktop, and there is some really cool stuff. I know Matt Veloso on Twitter has been talking about how he's been coding using remote desktop, using his Duo and whatnot, which is really cool. But there are just some things where I want to truly invest and immerse and need a bigger screen, and that's where my ARM device, my running Windows will be. Like the Surface Pro X is the one that I have. That's where it gets a little bit more, I could be more productive. But the two work great together, and I love carrying them around because they're so light together. It's like I don't have anything in my bag. And sometimes I worry, did I leave my Surface Pro X at home?
Yep.
So
Well,
All right.
with that, I know we're a little bit over time. Thank you for making the time. All right,
Appreciate it.
again,
Thanks, guys.
thank you so much. Really appreciate it. Can't thank you enough. Until next time, we have another 2 quick wrap-up notes here. Number one, we do have a user research session that's following it. It actually started 3 minutes ago because we ran just a little bit over. For those of you out there who want to participate, we will be doing a session on, interestingly enough, on using Gmail and Outlook email clients. So if you have used either of those clients, I'm actually going to drop it here in the chat window. You feel free to pop over there and participate in that user research session. We'd love to get some more of your insights, as always. And then coming up next at the end of this month on the 30th, we'll actually be doing a special webcast. It wasn't in the newsletter, but we have it planned. It is in the works. So stay tuned between the Answers Forum. We'll announce it in the newsletter just before. So if you look at the newsletters, it'll be a day or two before that actual date that you should receive that. But we'll be doing something special in that time frame. I don't want to completely spoil the surprise, but just mark down September 30th on your calendars, and we'll see you again. It'll be technically the October webcast, even though it's the last day of September, but it's super special and you won't want to miss it. So anyway, housekeeping notes taken care of. Go visit us on the user research session. And again, to all the listeners and viewers out there, I should say, thank you for making the time. We really appreciate it. Thank you to our guests. And with that, we'll call this one a wrap.
All right. Thanks, guys.